Okay, my friends, this is going to be interesting. I have a whole new perspective on the Standard Model. Now, my friend Pedro sent me this morning. He was with NASA and the European Space Agency. He understands this stuff pretty good, so he tips me off to a lot of things. And this is called the most successful scientific theory ever, the Standard Model. Don Lincoln at Fermilab has also made videos saying that it is the most successful model ever, and I disagree with that. Let's see what they have to say. Quantum Magazine, here goes.
400 years ago, Galileo started piecing together the basic principles of reality, what we now call modern science. But the questions he was trying to answer are as old as humanity itself. What are we made of? What are the fundamental building blocks of the universe from which you, me, the stars, and everything else is constructed? In the centuries since Galileo, thousands of theories and experiments have peered into smaller and smaller distances, converging on a single picture of the structure of matter. This somewhat daunting-looking formula is where we end up. It gives the correct answer to hundreds of thousands of experiments, in some cases with an accuracy that is unprecedented in science. It is, by any measure, the most successful scientific theory of all time.
Well, what is it based on? It's based on a proton, which is huge. It's 1,830 times bigger than an electron, but it seems to have the same charge as the electron, but it's opposite. And the tiny little electron doesn't, for some reason, come back together with the other charge. I say that is not correct at all. The center core is made of dipoles, not just a positive. Let me explain, because if you can understand this, God bless you. I went through all this stuff, and I wrote all these kind of things, and they just never made any sense to me, because everything has to be a dipole. Once you get into this, it's strictly theoretical. There's no experiment that shows any of this. Mine does. Okay, these are the assumptions that are being made, is that there's strong force, electromagnetism, and a weak force. And I'm not totally against that. I agree with that. There is a very, very strong force, and that's where you have the gluons, which make your electrons. That's what we actually broke apart. That's why I think when they come back together, we got a ton of electricity. Okay, my friends, this is from Fermilab, and they say, what's the point? And they're showing the two smallest particles that anybody has seen. And that's still the two smallest there is the electron neutrino and the muon neutrino. This one is a fixed particle. That one is really almost has no mass, and I will show you that. And he's saying the same thing, Standard Model, the most successful theory ever. Well, I don't agree with that. And I agree with exactly what they're saying about these two particles, because they can see these actually show up, but they just see them in the debris as the smallest particles that exist. But they also say the quantum foam exists, where empty space isn't empty. It's filled with these particles of light, which is the particles I'm going to show you now. So this really puts a real damper on the Standard Model, because it's going to be a dipole. Let me show you exactly how the Standard Model should be constructed. Alright, what you're looking at here is electricity turning into light, which is a light emitting diode, or you're seeing light turn into electricity through a light absorbing diode, which is the same thing. The emitter is also an absorber, and I can prove it. This is a light emitting diode right here. This is a little meter. Now, in the 20 scale, I'm going to light this up with a little laser. Now, red is not powerful enough to make that go. Watch, you see the red? Watch. See the red all over there? I put it on there, not getting any increase in the meter. Look at the meter and look at the red, nothing. All right? So the red, we know, we got red. There's no problem having the red, but it's not powerful enough to turn on a voltage. So what would? How about a blue? You see that one there? That's the blue. It looks like much less powerful. But watch this. Boom. 2.4 something volts. Look at that thing glow. 2.45 volts. So I just forced electricity, which is light. Light is electricity. There it is right there. And each one of these is an electron. I never knew the dark matter was attached to the electron. They see them at CERN. They have no idea how they got... They came in as electron neutrinos back to back, just like this, black and whites. And in their collisions, they have them separated out into electrons primarily. Then they get some photons, and then they get these, the black and the white, which is a separated sterile muon and electron neutrino. And then they get a lot of these showers, which we do too. I mean, there it is right there. This is what the normal configuration of a photon is. I have them in green, all the different colors. And when it comes to the Venturi, which is a restriction, they break their strong nuclear force, their gluon force, which is strong as hell. These are locked on here. They just never ever... I didn't realize you could possibly break them apart, because that's a monopole. Once you break it apart, that black right now is a monopole. Those are all by themselves. And the white is electron shower. That's a monopole too. And you can see the light is pretty obviously accelerating. You see that that's where the particle is, and that's where it breaks, and this is where it comes back together. We see the Higgs fields all over the place here. Single slit, but we have interference patterns. We got a lot of talking about to do. All right, here's another one I was looking at, Star Talk, with Neil Tyson, and he's talking about nuclear fusion, how it's going to change everything. I agree. But we have to be in the world of reality about this fusion. All right, here's another one. I'm not going to get into this one, but they're all talking about the fundamental forces of nature. And the crazy thing is, that is it right there. That's a Dirac neutrino, the black and the glowy part. Either it's red or blue or green or whatever, but this is the part that can get really powerful, and this is a fixed particle, exactly as they say at Fermilab. And here's what they had to say here. Oh, whoops. Oh, this guy here, yeah, Marvin Adams. He was on national news the other day with the Department of Energy. We're looking to figure out these fission and fusion, and we're hiring, and anybody that has any information, get a hold of us. And I did. I tried, but I didn't get a response. So maybe it just didn't get through. Maybe I'll try again. Okay, here's something else about the sun's sizzling corona. It's 10,000 on the surface, millions out at the corona. The reason is the particles that are being expelled from the sun are scrubbing the zone that the sun has to push through. I'll show you exactly what the sun looks like as it's going through space. All right, here's where the sun is, right here. And it's going through space on the arm of the Milky Way, being dragged through space, and it's spinning at the same time. So right there is the collision zone. Just like our laser, here is the collision zone. We haven't even hit these particles yet. This is the laser just pulsing. That's the tip of the laser. Whoops. Just like the sun. As it hits those particles, out in front, it glows like hell. That's why it's 1,000,000 degrees. Back here, it's only 10,000 because it's not in that glow. You see this? This is the whole progression. That's where I just showed you the glow. It hasn't even started to interact with these particles yet. However, you see them glowing. Now, why would they glow when this is way back here? I could see when they're hitting them, they glow, and they do. But they're still glowing out here because this whole space is being compressed. And when you compress anything, it creates energy and it glows. Any compression. And here is the wave being compressed because of the Venturi, which pulls the particles through. It's an accelerator. And it is accelerating it very fast. That particle now, which was just at the tip of the wave, is and bam, right into the accelerator vortex. Well, it's a restriction. And at that restriction, the white leaves the black go around, the white goes through, and then they have to come back together, and that's what they do. If we could put a harvester device right there, we might be able to get unlimited amounts of absolutely stunning amounts of energy. And this is just, I'll show you this Higgs fields. This is the particle, actually, the light particle. And they come in green, they come in blue, they come in red. See, this is the progression of the light turning into the separate particles, the muon electron neutrino showers. Now, this is, I believe this is what they would call the tau. It's got two blacks and only one white. Then it goes into the photons as it stacks up, and it crushes itself and starts to gain energy. And you see 2 and 2. Now there may be 2 and 2 here, but I don't see them. I see one white and 2 blacks. But the white could be just, I don't know. Here I can see it quite obviously. Here it gets more glow, and then it explodes. And the more glow it gets is more luminosity. Luminosity is a function of energy. The more glow, the more energy. It's absolutely certain that that is true. Here's the green. It's the same particle. It's just that it's got a lot more energy. Here it's, and I believe, the tau phase, and here it goes into the photon phase, and the leading white will charge up because it's bumping into particles, and it becomes real glowy, and it'll flip to the back. This is all the same particle. All these shots are a whole batch of the same particle at once because it's going so fast. It's light. And this was using a CMOS smartphone, which they are using now for cosmic ray detectors. And that's exactly what this is. Muons and electron neutrinos are cosmic rays. Look it up. All right, this is the Russians in space. Zero gravity in a vacuum chamber. They spit in here these little dust particles with an extra electron, which is called a charged particle. They came in, and this is what happened. And the reason it happens is because this is a black hole. This is what everybody's been talking about, the black hole. Well, that's only because these are charged particles. They have an extra electron on them, which forces the dark particles to collect in the center, and they are attracted to them, and they create a core around them, exactly as our Earth does. This is no more than an Earth ground, but it's in space. On Earth, all of these would be slammed right down to here, to the ground, all of them. But here it's in space. They can circle, which is exactly what's happening on our Earth. All the electricity goes to the center of our Earth. I don't care if it goes from the south, from the north, from the east, from the west. It all goes into the interior. That's what we call it Earth ground. Static, zzz, lightning, zzz, electricity, zzz. That's why you have to have things grounded so it doesn't go through you to get to ground. It wants to be into ground. That's the key. We separated the white from the black. It wants so desperately to get back to the ground. That's where you get electricity from and lightning. We did it. I think we can get it free right now. All right, in my mind, I'm thinking if we can shoot that laser through and separate it like we have done, and collect that white, and it wants so desperately to get back to the black that going through our devices, it will power on and do whatever we want. That's what electricity is. And that is what will happen here, as far as I can see. If it's separated, it wants terribly, desperately to get back to the black, just as the electricity we put right now going into the ground. It will go through your body and explode your body to get to ground. That means it can drive equipment, it can drive motors, it can burn things, it can do all that stuff to get back to the black matter. So we need to be able to get the black on one side over here and get the white going through until it can get back to the black and drive our devices, charge our batteries, keep this thing going, and then you have free energy. And this is very, very cheap stuff if it works. And I think I showed you, or I will, that you can turn on these things with light, these little diodes, and harvest that energy back. And if you can get just strictly the white, which we can, and we can squirt it all day long onto a substrate. It's not just one big bang and you got to start over, and it just makes a big pop. We can squirt it like a hose right onto the substrate, and it's just squirting electrons, and raw electrons are absolutely incredible. The increase of energy, if it's true. They say it can go into the millions or even trillions of electron volts. And you're only starting out with hundreds of thousands. So if you can go into the millions, you got a lot of free energy. Okay, so what are my claims? I've heard everybody else's claims. Here's my claims. This is the new dipole electron flood theory. That means that everything is made of dipoles. And a proton, which is normally they consider one big positive with some quarks and a little of this and a little of that in there. Well, it's 1823 dipole electrons, which are these. They have a dark and a glowy side. I'm going to call them electrons because that's what they are. They do exactly what we always thought an electron did. Just nobody knew about the black. That's all. The electron burns stuff. It will electrocute you. It will drive motors. That's what that does. Muon is the carrier of that particle. It has almost all the weight. So these are the neutrinos. I showed you the photons. This is how to get a hold of me about this. Now, this is my claim right here, is that right there is all that exists is the black and the white. That's it. Now, here's a little more detail. Is here. What is my claims? I say all particles are dipoles. That's all that exists is these two particles, the W and the Z boson. All the rest is just accumulations and variations of these two particles together. This is what we call an electron, yes. The muon neutrino, electron neutrino attached is what is an electron. All right, gravity, collision, they can separate. Gravity is being pulled to the earth. The white glowy part will always, always, always be pulled to the earth. Electricity. Bzzz. Now, it can get big, the glowy part. Some guy really was, I get criticized a lot. So, oh, when you say glowy, I just decided you must be an idiot. Well, you call it anything you want. I call it glowy, sir. All right, it's a powerful little particle that glows, which means glowy. All right, it can unglow. How about that? This is glowy. This is glow-S. Now, the black never changes. You could be big with the W boson. The Z is that. Its case is closed for that. And this has no weight that I can determine, and that is a bowling ball. And you can see it in the house experiments where it knocks the house down after an atomic bomb. The first ones that hit are the glowy ones, and the next ones are the bowling ball ones. They just knock the house down. Now, there's 1,823 electrons is what one proton would equal. So this is a proton in my world, but it's 1,823 of these. Now, 1824 means you don't want to give one up or take one in, so it becomes a neutron. It's neutral. Now, the core construction is, I believe it's almost like an eggshell. I believe the dark matter goes to the center and is coated by the white matter outside of it. In certain globs, they become pretty stable. There's just enough black matter in the inside to coat the outside with white, and it becomes a periodic amount of stability. That's what it appears to me at this point. I could be wrong. Now, the wrong assumptions that they're working on right now is that a vacuum exists. There's no vacuum anywhere. And Family Lab says yes, there is a quantum foam out there, but they have no. I mean, that's what they say it, and then they just walk away from it. Well, if there's a quantum foam out there, what about the things that are moving through it? What about the redshift coming at us? Don't you account for that pushing and shoving a little bit? I say the redshift is not because everything's going away. I say it's because everything's slowing down. All right, it may have some redshift because it's going away, but I think that mostly it's slowing down as it's coming to us. Now, light, they say, is only one speed. I can show it slows down, accelerates. I see that the red is much less powerful than the green. I don't know if they're going the same speed, but I can tell you there's a hell of a big difference. Standard model rules, they never work because there's only dipoles. Photon's mass, they say, is 0. That's absolutely wrong. It's got a mass. The photons are 2 of these black particles, and they have a mass, and I have a weight for them. The weight of each one of these particles together is 0.0054856, I think it is, atomic mass units. And if you multiply that times 1,823, you end up with 1 proton. So that means there's 1,823 in the center. They always called it a proton, and they always thought it looked like one big ball, like this. And it had a charge. And then they said a neutron was like this, and it only weighed 1 more electron more than a proton. and they didn't pick up on the connection. It's absolutely amazing how it's amazing how they miss so much. Anyway, these are all my new claims, and I have much deeper details on this. Hold on. I got them all. I got it coming out of my ears. But it's this first phase, initial draft. The new model is electron flood theory, which I have proven. I'm not saying it's a theory anymore. I'm saying it's a model that works. And it is much more successful than the standard model, which can't even predict gravity. Gravity is the dark. Gravity is the black one. I showed you in outer space. All the white ones want to come down to it. The white ones are, everything that exists is made of these two. And the white one will always try to come down to a black hole. So inside of the Earth, as far as I'm concerned, is loaded with this dark matter. Whether it's just loaded in clusters attached to other clusters, or whether it is literally a hole. I don't know, but I can tell you what, every single one of these glowy ones will always go to ground. Every single time. And it will go around you. If you held that wire and another wire was going to ground, you could hold that wire and the other wire would take the electricity and go to ground. That's why lightning does all this stuff in the air. And they're asking about that now. Well, we just all figured out how lightning works. I'm not kidding you. It's amazing. That's why this is a never-ending challenge to keep up with all the claims. But nobody responds, so it's very, very, it's frustrating.